Hello everyone, this is Sri Guru over here. In the previous video, we have discussed about the experimental study of photoelectric effect and Einstein explanation of a photoelectric effect. Today, we are going to discuss about which required for KCET, NEET and JEE, some of the most important equations. Look at one by one. Energy radiated from a source is in the form of a small packets which are known as a photon. Photon is not a material particle, remember. According to Max Planck's, the energy of the photon is directly proportional to frequency of the radiation. That is, E is proportional to nu. If you remove the proportion, then we have to substitute a constant. That is, E is equals to h nu is equals to, where nu is nothing but c divided by lambda. If you substitute the value of h and c, the value of h is 6.642 into 10 raised to minus 34 and c is 3 into 10 raised to 8 meter per second. If we simplify this, we will get 1240 divided by lambda in terms of nanometer electron volt. Next, the momentum of photon is given by P is equals to E divided by C, where this E is nothing but, in the previous equation, E is equals to h nu. We are going to substitute this value here, h nu divided by C, as you have seen in the previous equation. If we simplify this, you will get h divided by lambda. If the source is 100% efficient, then the number of photons emitted per second by the source can be given by power of the source divided by energy of the photon, that is P divided by E, which is equal to P divided by h nu or P lambda divided by hc. Intensity of the light is the energy crossing per unit area per unit time perpendicular to the direction of propagation. Already we have discussed this concept in the previous video, and that is given by I is equals to E divided by AT, where that A is nothing but area, T is nothing but time. But this E divided by T is nothing but a power. Therefore, that is P divided by A. For a point source, intensity at a distance r from the source. If we consider the area is a circular, then I is equals to P divided by 4 pi r square. Look at some numericals which are appeared in a board exam in Karnataka. The first problem is the work function of a cesium metal is 2.41 electron volt when a light of frequency 6 into 10 raised to 14 hertz is incident on a metal surface. Photo emission of photoelectron occurs. They asked to find out the first energy of the incident photon, next maximum kinetic energy of the photoelectron, and also given Max Planck's constant h is 6.63 into 10 raised to minus 34 joule seconds, and 1 electron volt is equals to 1.6 into 10 raised to minus 19 joules. Energy of the incident photon is given by E is equals to h nu, and h the value is given here, and nu value is also given. Frequency, that is 6 into 10 raised to 14 hertz. If you substitute this value 6.6 into 10 raised to minus 34 into 6 into 10 raised to 14, after the simplification we will get 39.6 into 10 raised to minus 13. Energy is measured in terms of joule. This is the first one, which is the energy of the incident photon. The second one, they asked to calculate the maximum kinetic energy of the photoelectron. According to the Einstein equation, K maximum, kinetic energy of the photoelectron maximum, which is equal to incident energy minus work function. The incident energy already we have calculated here. That is, we have written in the form of 10 raised to minus 19. That is 3.96 into 10 raised to minus 19 minus the work function also given, that is in terms of electron volt. We have to convert this in terms of joules. Therefore, I have multiplied this 2.14 into 1.6 into 10 raised to minus 19, that is the value of 1 electron. After the simplification, we get maximum kinetic energy 0.5 into 10 raised to minus 19. This is the second problem. Light of frequency 8.41 into 10 raised to 14 hertz is incident on a metal surface. Electrons with their maximum speed of 7.5 into 10 raised to 5 meter per second are ejected from the surface. Calculate the threshold frequency for a photo emission of electron. Also find the work function of the metal in an electron volt. This is one of the simplest problem. And also, as we have seen in the previous, the Planck's constant value 6.625 into 10 raised to minus 34 joule seconds, and the mass of the electron is given 9.1 into 10 raised to minus 31 kg. These are the given terms, frequency and the velocity of the ejected photoelectron. As we know that energy of the photon E is equals to h nu, and h value is 6.625 into 10 raised to minus 34 given. If you multiply this with a incident frequency which is given 8.41 into 10 raised to 14 hertz, after the simplification we will get 53.9 into 10 raised to minus 20 joules. And next we have to calculate kinetic energy by using the formula half mv square, because v is given, m is also given, mass of the electron, that is half into 9.1 into 10 raised to minus 31 into 7.5 into 10 raised to 5 whole square. After the simplification we get 25.59 into 10 raised to minus 31 joules. And this is the photoelectric equation. The work function they asked to calculate here. First, the work function, threshold frequency. For that I have used work function is equals to h nu, incident energy, minus maximum kinetic energy. And as we have calculated earlier, h nu value 53.9 into 10 raised to minus 20, and also we have calculated kinetic energy 25.59 into 10 raised to minus 20. If we simplify this, we will get 28.31 into 10 raised to minus 20. Just I have taken here this h to the left side, then it goes to denominator. The value of h is 6.625 into 10 raised to minus 34. After the simplification, this we will get 4.27 into 10 raised to 14 hertz. This is the threshold frequency which is required for the ejection of photoelectron from the metal surface. And the second, they asked to calculate the work function. That is, work function is equals to h nu naught. The value of h is given 6.625 into 10 raised to minus 34, and frequency we have calculated in here 4.27 into 10 raised to 14. After the simplification we will get 28.28 into 10 raised to minus 20 joules. But they asked work function in terms of electron volt. For that I have divided this equation with 1.6 into 10 raised to minus 19. After the simplification I got 1.7 electron volt. This is the simplest one. If you simplify this, you will get the 5 marks in board exam. These are some questions asked in a KCET. Look at the first one. The maximum kinetic energy of the photoelectron depends only on. The kinetic energy depends on the frequency of the incident light, not on the potential applied to the electrodes or the incident angle or the pressure. The same equation is also asked in 2018 CET. This is the second option is right. Kinetic energy of the ejection photoelectron depends on the frequency. As the frequency of the incident light go on increases, the kinetic energy of the photoelectron also increases. Look at the second question. The variation of the photocurrent with a collector potential for a different frequencies of the incident radiation nu 1, nu 2 and nu 3 is as shown in the figure. If you properly observe the diagram, here there is a saturation current. That means all the three radiations have the same intensities, therefore they got the same saturation current, but their frequency is changes, therefore their stopping potential is also changes. But as we go on increasing the frequency of the incident radiation, the stopping potential is also gradually increases. Therefore, this incident frequency is less. The stopping potential is also less. Therefore, the option C is right. Option C is right. Nu 1 is less than, nu 2 is less than nu 3. This is the second easiest graphical question. Third one, from the following graph of the photo current against the collector plate potential for two different intensities of light I1 and I2, one can conclude. That means he asked which out of this one is right. Here the saturation current is different, therefore their intensity is different. As we go on increasing the intensity of the incident radiation, the saturation current is also increases. Therefore, if we properly observe the diagram, the I1 must be less than I2. Option C must be right because the incident intensity is less for the I1 compared to the I2. Next question. A light of certain frequency and the intensity incident on the photosensitive material causes the photoelectric effect. If both of frequency and intensity are doubled, the photoelectric saturation current becomes quadrupole, halved, doubled, unchanged. Only we have to observe here the photoelectric current is directly proportional to intensity of the incident radiation. Therefore, but the photoelectric saturation current does not depends on the frequency of the light. Therefore, the option C must be right here. Option C is right. Next, fifth one. Light of two different frequencies whose photons have energies 1 electron volt and 2.5 electron volt respectively successively illuminate a metallic surface whose work function is 0.5 electron volt. Ratio of the maximum speed of emitted electron will be. He asked to calculate velocity of the ejected photoelectrons in terms of ratio. Therefore, first I have written here the given terms. One E1 for the energy of the first incident photon 1 electron volt, energy of the second incident photon 2.5 electron volt, and both are incident on the same material. Therefore, the work function must be same for both, that is 0.5 electron volt. I have written here two equations for the two different kinetic energy of the ejected photoelectron from the metal. That is K1 is equals to E1 minus phi 1, K2 is equals to E2 minus phi 2. Equation 1 divided by equation 2, then K1 divided by K2 is equals to E1 minus phi 1 divided by E2 minus phi 1. Fine. Just I have to write here V1 square divided by V2 square because kinetic energy is nothing but half mv square. 1 divided by 2m is get cancelled here, therefore the remaining term is V1 square divided by V2 square. If we substitute these values here, E1 is nothing but 1 electron volt minus work function for the metal is 0.5 electron volt divided by 2.5 minus 0.5. After the simplification we will get 1 divided by 4 here. But after that, the remove the square, I have taken here square root. If we take the square root for this, we will get 1 by 2. Therefore, the option C must be right here. These are some few examples asked in Karnataka CET. Thank you for watching my video. Don't forget to like and share and subscribe. Thank you.